Today we are going to see the another important concept in ray optics, that is refraction through a prism. Kindly close the door. Sound is coming from the next class. Yes, thank you. A prism is a homogeneous, transparent medium enclosed by two surfaces inclined at an angle. Prism is a homogeneous, transparent medium enclosed by two plane surfaces inclined at an angle. See this diagram? These two are the transparent refracting surfaces enclosed by an angle. The angle included is nothing but angle of prism. This is the definition of a prism. It is a homogeneous, transparent medium enclosed at an angle. The surfaces are called refracting surfaces. The angle between the refracting surface is called angle of friction. Prism, sorry. See the diagram. The angle of prism is denoted by the symbol A. This is the incident ray falls on the one of the refracting surfaces. The angle made the incident ray with respect to the normal. Normal is the perpendicular line drawn for the refracting surface. The dotted line is called normal. This line is normal. This is the incident ray. The last line is called emerged ray. I is the angle of incident. Here E is the angle of emergent. If there is obstruction for the incident ray, this light will be traveled as in the dotted line. The mari dotted line la vandirukku. But due to the refraction, the final ray direction will be like this. The angle between the emerged ray and incident ray is delta. That is called angle of deviation. The angle between the incident ray. This is the incident ray projection. This is the emerged ray. The angle between these two lines is angle of deviation. That is called a delta. Okay. Inside the prism R1 and R2. R1 is the refractory angle with respect to the incident ray. And the same line will be incident on the other surface. That is called R2. Now, based on this geometry, we have three important formula. How to find out the angle of deviation? What is known as first angle of deviation? Take down this. Angle of deviation is the angle between incident ray and emerged ray. It is the angle between the incident ray and the emerged ray. It is denoted by the letter delta. Okay. The angle of deviation is denoted by the letter delta. The formula is I plus E minus A. Very important formula. Kindly note down this, where I is the angle of incident. E is the angle of emerged ray. A is the angle of prism. Next formula, governing formula for this A angle of prism is equal to R1 plus R2. The refraction angle inside the prism. Okay. Some important condition related to angle of prism. When the angle of deviation is minimum, I is equal to E. in a position of minimum deviation, the delta is denoted as delta suffix m. I is equal to E. Angle of incident is equal to angle of emergent, provided the position of minimum deviation or minimum angle of deviation. When I and A are small, the angle of deviation with respect to the refractive index is mu minus 1 into A. In a position of minimum angle of deviation, I is equal to E. In addition to that, R1 is equal to R2. That is equal to R. This is also important. When you substitute this I is equal to E and R1 is equal to R, the I can be written as A plus delta M divided by 2. It is obtained from this formula actually. Here delta is equal to I plus E minus A, isn't it? I plus E, delta is equal to I plus E minus A. When the angle of deviation is minimum, it becomes dm. I is equal to E. Therefore, it can be written as I plus I. I plus I. That is A. That is 2I minus A delta M. Therefore, 2I is delta M plus A. Therefore, I is equal to delta M plus A divided by 2. This is the condition. Suppose if you forgot this formula, you derive that from this basic formula. This is the main relation for the prism. Already we have A is equal to R1 plus R2. For the minimum position, I have already told R1 is equal to R2. That means R plus R, 2R. Therefore, R is equal to A by 2. Understand? For the minimum position, I is equal to A plus delta M divided by 2. R is equal to A by 2. Using these two expressions, we can calculate the refractive index based on the sign Snell law, sin I divided by sin R. Substitute the value of I here, A plus delta M divided by 2 divided by sin A by 2. Understand? switch on பண்ணுங்க. No sound. Again, it is switched off.
Finished, sir.
Have you finished?
Yes, sir.
Okay. Consider this next prism diagram. The diagram explains the dispersion of light. What is known as dispersion of light? It is a phenomenon of splitting of white light into the constituent of color. White light is split up into constituent color. That is called dispersion of light. When the light incident on the prism, it will be dispersed into different color. The color consists of VIBGR, violet. You know the VIBGR colors?
Yes, sir.
Okay. Here in the diagram, they have mentioned only the extreme and two extreme wavelength colors in addition to the medium wavelength, that is yellow. Larger wavelength red, smaller wavelength violet. See the diagram. The violet light dispersed in a greater angle, delta V, whereas the red light dispersed in a smaller angle. Yellow light between delta V and delta R. But the red light has more wavelength than the violet. When the light has more wavelength, the angle of deviation is minimum. That is the condition. Understand?
Yes, sir.
It is a phenomenon of mu is equal to a plus b divided by lambda squared plus c divided by lambda power 4. On the contrary, the refractive index of the red light is less than refractive index of violet. Understand?
Yes, sir.
Next one. Another terminology, angular dispersion. It is the difference between the angle of deviation of two colors is known as angular dispersion. Write down this, the difference in deviation you need two color. Angular dispersion. The angular dispersion is, say, delta V, delta R. That is equal to mu V. The angle of deviation of the violet minus angle of deviation of the red light. Delta is equal to mu minus 1 into A, or in other words, mu suffix V minus mu suffix R into A. Another important term, dispersive power. This is called angular dispersion. Next terminology, dispersed power or dispersive power. It is denoted by the letter omega. Angular, it's the ratio of angular deviation divided by mean deviation. delta V, delta R divided by mean deviation is delta. Mean deviation, that is delta, is obtained by adding the two deviation, delta suffix V plus delta suffix R divided by 2. Already we have written delta V minus delta R as mu V mu R into N. Mu V minus mu R into N. This formula can also be expressed in terms of refractive index mu V mu R divided by u minus 1. Where mu is mu V plus mu R divided by 2. That is mean refractive index. Okay, shall we go to the problem?
Yes, sir.
Students, see this first problem. A thin glass of refractive index 1.5 has optical power of minus 8 D. D means diopter. That is a unit of power. Its optical power in a liquid medium with the refractive index is 1.6 will be a thin glass. First condition, a thin glass has the optical power. What is the value? Minus 8D. Its optical power in the liquid. What would be the optical power when it is immersed in the liquid of refractive index 1.6 will be? The problem related to lens. First lens optical power. When the lens is in the refractive medium 1.6. The same lens is in the another liquid medium, what would be the power? நான் சொல்றது புரியுதா? லென்ஸ் ஒரு மீடியத்துல இருக்கப்போ அதனுடைய பவர் வந்து -8d. அதே லென்ஸ் இன்னொரு மீடியத்துல இருக்கு, அதோட மீடியத்தோட ரிஃப்ராக்டிவ் இண்டெக்ஸ் 1.6 அப்படின்னா அதனுடைய பவர் என்னன்னு கேட்கிறாங்க. This is a comparison. The problem consists of two cases. First case, the power and refractive index of the glass is given. In the first case, the length is placed in the air. In the second case, the length is placed in a liquid other than air. The liquid has the refractive index 1.6. So what would be the power of the lens when it is placed in the liquid of refractive index 1.6? You have a power formula actually. 1/f, that is a governing formula for the spherical surface. Do you know that formula? Already we saw it in the last class.
Yes.
1/f is equal to u minus 1. Tell me, 1/r1 minus 1/r2. This is the governing formula for the spherical surface. See, that is a lens maker formula. In other words, lens maker formula. Power is equal to 1/f. Understand? Power is equal to 1/f. Therefore, this can be equated as P is equal to 1/f is also power. Mu is the ratio of what? First condition.
Glass.
Length is placed in the air. Understand? Apo mu g divided by mu air minus 1. 1 minus r1. 1 minus r2. Say P. So for the second case, this is the case 1. For the second case, the power, let it be P dash. We have to find out the P dash. In this case, the length is placed in the another liquid, not at air. Therefore, the formula is modified as mu g divided by mu L. 1/r1, 1/r2. This is the equation 2. When you divide this equation 1 and 2, r2 divided by 1 becomes P dash divided by mu g, mu L minus 1. Here, mu g, mu air minus 1. That is into in the numerator here 1/r1, 1/r2. Here also 1/r1, 1/r2. Both get cancelled. And then finally, P dash divided by P. All of you listen here. Now, what is the value of mu g?
1.5.
Very good. Aprom mu L next liquid la enna pannirkom 1.6 la immerse pannirkom divided by 1.5. what air gena 1. Correct ah? Ipo idu simplify pannu. Numerator simplify panna enna varuma? See the LCM 1.6, 1.5 minus 1.6. In the denominator, 1.5 minus 1 here, 0.5. Isn't it? The numerator 1.5 minus 1.6, what is that value? 0.1. That is a minus divided by 1.6. Here, denominator 1.5. Listen and then write. Here minus 0.1 divided by 1.6 into 0.5. Multiply 10 and divide by 10. It becomes the numerator 1, the denominator 16. 0.5 means 1/2. 0.5 means 1 by 2. Understand? This is 1 by 8. Any doubt?
No, sir.
Therefore, P dash is 1 by 8 into P. Already in the problem, the first lesson, the first length's power is given. What is that value? Minus 8. Therefore, already here also we have a minus 8. I missed that minus here. Minus of minus plus 1D. This is the answer. Understand, student?
Yes.
Yeah. How many students are attending the class today?
4.
Only 4. What about the others? They are not interested, huh? Absentee, sir. Okay, no.
Sir,
Yes, sir.
school students only need to attend the online class.
Just a minute, sir. I will come.
School students only attend the online class.
Oh. Other students are day scholars now. They are repeaters, I think.
Yes, sir. Yes, sir.
Okay.
It's a doubt session and regarding the offline mode.
Okay. They are attending the offline mode, huh?
Yes, sir.
Okay. Next problem. Students, see the next problem. The first question, the option A. Answer is option A. The power of biconvex lens is 10 diopter and the radius of curvature of each surface is 10 centimeter. Then the refractive index of the material of the lens is 3 by 2, 4 by 3, 9 by 8, and 5 by 3. I have given a formula already. Power is 1 by F, where F should be in terms of meter. Suppose if you substitute the value of F in terms of centimeter, this formula is modified as 100 divided by F. It is in terms of centimeter. Understand?
Yes, sir.
F வந்து மீட்டர்ல போட்டீங்கன்னா 1 by F. F சென்டிமீட்டர்ல போட்டா நீங்க என்ன பண்ணணும்? ஃபார்முலாவை 100 divided by F. See the point, they are asking the refractive index. They are asking the refractive index. How to relate this? 1 by F is equal to mu minus 1 by r1 1 by r2. Here the radius is given as 10 centimeter for both cases. All of you listen here. The lengths consist of two spherical surfaces. One is the left hand side, another one is the right hand side. For this left hand side portion, the center will be in the right hand side. Say this is the radius. For this one is the radius. Understand? Usually, as per sign convention, the radius are measured from the optical center. This is the optical center. When you measure the distance r1 from here to here, it will be positive. When you measure the distance r2 from here in this direction, it is negative. Very important condition. I have already given this note. The convex lens r1 is positive, r2 is negative. Therefore, because the r2 is measuring in the opposite direction of ray of light, therefore r2 is minus 10. R1 is 10 centimeter, R2 is minus 10 centimeter. The formula is modified as 1 by R1 plus minus of minus plus, just to substitute the value. Here, what is the F value? P is given. What is the P? 10 diopter. 100 divided by F. Let us take the value F in terms of centimeter. F 100 divided by P, 100 divided by 10 centimeter. Therefore, it is 1 by 10, mu minus 1. Here, 1 by R1 plus 1 by R2, 1 by 10, 1 by 10. Mu minus 1, 2 by 10. This one, 1 by 10. Both sides, the denominator 10 is here. 10 cancel. One by 2 is equal to mu minus 1. Therefore, mu is equal to 1 by 2 plus 1, 3 by 2. That's all. Answer is A.
Completed.
When the white light moves through the vacuum, when the white light moves through the vacuum, all colors have the same speed. Different color have different speed. Violet has more speed than red. Red has more speed than violet. Which one is correct, ma? A, B, C, D. What? When the light is passing through the prism, the dispersion takes place. That means when the light passes through the glass, glass has a diffraction medium. Okay. But when the light passes through the vacuum, there will not be any medium. As a result, there will be no dispersion or deviation. White color will passes through the vacuum as a white color. Therefore, all the light have the same speed. There is no dispersion. Therefore, the option is all color have same speed. When the light passes through the vacuum, dispersion will not take place. That means all color have same speed. That is the answer. Students, see the next problem. A given figure shows three cases of ray passing through a prism of refractive edges A. The case corresponding to the minimum deviation is. The case corresponding to the minimum deviation A. In three cases, the prism is given. In the left hand side, incident ray falls, and the right hand side, emerged ray comes out. Okay, this is the angle of deviation. This is also angle of deviation. That is here, angle of deviation. I'll have to listen here. One important note, the minimum angle of deviation occurs when the light passes through the medium is parallel to the base. Then only the angle of deviation is minimum. This is the angle of deviation, there is a minimum angle. Now, compare the three lights. See the inside refraction of the prism. This one, and this one. The middle, the ray passes parallel to the base approximately. This line is parallel to this line. As a result, this emerged ray produces minimum angle of deviation. Understand, children?
Yes, sir.
Okay. Therefore, the option is 2. When the refraction light inside the medium is parallel to the base, it produces minimum angle of deviation. That is a condition. Next problem. A ray of light passes through the equilateral prism such that the angle of incident is equal to angle of emergent and latter is equal to 3/4 of the angle of prism. The angle of deviation is a ray of light passes through the equilateral prism such that the angle of incident is equal to angle of emergent. The first condition is I is equal to E. And the latter is equal to 3/4 of the angle. Latter means angle of emergent is equal to 3/4 of the angle of prism. This is the condition. How to find out the angle of deviation? That is a question. The question is find out the delta. Very simple one. Delta formula I plus E minus. Here I and E are same. Therefore, simply substitute the value as 3/4A plus 3/4A minus A. This is 2 times. 2 into 3/4A minus A. It becomes what? 3/2A. Minus A. 3/2 minus 1 na evlo marum? Hmm?
1/2.
Yes. Very good. That means A/2. Delta. In this problem, the answers are given in degrees, 45 degree, 39 degree, 20 degree. But we have obtained the delta in terms of A. This is the equilateral triangle. Therefore, the angle of prism, 60 degree. 60 divided by 2, 30 degree. Understand?
Yes, sir.
Have we finished, students?
Yes, sir.
In the next class, we'll solve more problem. Kindly revise all the portions when you come to the next class. Okay. Okay. Thank you very much. Bye.